Hello, I'm Justin Smith, and welcome to another how-to on getting started in Designcenter NX CFD Designer. This is a gear motor assembly that I've simplified to do an early cooling analysis for fan selection. When you open CFD Designer, you'll notice that the functions are laid out in a way that you can move from left to right as you move through your workflow. So you could either start with a wizard or create a new project manually. But before we get started, we'll go ahead and check geometry. In this menu, you can select components to check and your analysis type along with a few other options. Once the check is complete, you can see what parts and features are causing an error. And checking the box for display will also add tags to those errors. I've already created a fan profile for the simulation, so I'll just replace the fan quickly. In most cases, I would also recommend using create lids. And you can simply select faces and openings that will automatically have lids placed in them. This is great for creating boundary conditions. Since we're using a fan, we won't need to add boundary conditions for this simulation, and I'll just add a custom one later. After running the check again, you can see that the geometry check is now good. Now that some of the prep work is done, we'll just use the wizard to create a new project. You can start out by naming your project and configuration, and then you can select your unit system or create a new set. I'll change the default volume flow units to make our fan sizing a little simpler. Then you can select your physical features and other parameters for your analysis, like external or internal flow simulations. You can then select your default fluid, and with both fluids and solids, you can always add a custom material by selecting New at the top right. And there's a wide range of both gases and liquids to choose from, along with your flow characteristics. The same material selection can be done with solids as well. Once you have done all this, you can set your wall roughness and set any custom parameters, then selecting Finish will automatically set up the basics of your project. Once the project is set up, you'll notice the volume around the part. This is the computational domain, and it can be resized if needed. You can go to the CFD Designer Navigator and view or modify your input data. I'll start by customizing the project tree and adding fans. Then I can select the fan type as well as faces for fluid exit and entrance. You can create and edit your own fan profiles by selecting Create or Edit. You can also do this by clicking on the engineering database, where there's a wide range of materials or other items that you can create. For this calculation, we'll just use the low flow fan profile that I created earlier. I also recommend utilizing clip section. This will give you a better view when setting up and viewing CFD results, especially when working with internal flow. In our case, the clip section allows us to seamlessly select and assign materials. The next thing we'll add is a volume source. Sources can be set to either volume or surface, and you may notice how I'm using a selection filter to select groups of components more quickly. This is not needed, but I recommend it for faster selection in cases like this. One of the last things we'll do before we run the calculations is we'll set up a few goals as well. You can see we have a wide range of parameters to choose from, and since we have surface temperature goals for the casing, I'll select average and max temperature goals, and I'll also have a max temperature goal for the coils themselves. Global mesh settings are also an important factor to take into consideration. The mesh will automatically set up for you when you run CFD Designer. But if you'd like something a little more coarse or fine, you can move the slider and change your minimum gap size to fine-tune your results. Before I run the study, let's add a few useful plots to view our results after the calculation is finished. We'll start with a general temperature cut plot, a surface temperature, a flow cut plot, and then a flow trajectories plot. In the case that you don't have a particular parameter in this list or you just want to remove one, you can just scroll down to Add Parameter and customize your list from here. I'll also make a clone of this project so we can just change the fan profile for a different fan option on this assembly. And then I can use Batch Run to select multiple projects to run in a single run. As this batch runs, I can also extract a goals plot as the solver runs, and we can see how our different parameters are converging. Now that the solver is completed, we can view the results. And looking at our key, I think we should adjust the temperature ranges to better represent the results we see here. You'll just need to click on the temperature, and you can edit or quickly change it by selecting to a plot or global temperature. Let's say I wanted to smooth this out to better represent the temperature distribution, so I can also increase the number of colors here. We can do the same thing with the temperature cut plot and even play an animation of the entire assembly, which can be exported if needed. Let's take a quick look at how the air flows around the motor as well. I can also compare my solutions by using the compare function and selecting the plots and projects I want to compare. If I wanted a little more direct comparison, I can even create a plot that shows the difference between the two solutions. In this case, the large fan seems to lower the temperature of the assembly by around 1.5 degrees. In this demonstration, we set up early design validation using CFD Designer to compare the potential design choices for cooling the skier motor assembly. CFD Designer helps you quickly validate your designs within Designcenter NX. However, for more precise results with more complex solutions that may require transient state calculations, FlowEFD contains all the tools you need to validate your designs. Thank you.